Hi everyone, and welcome to the sky this month for December 2025. My name's Paul Martinaitis, and this show is brought to you by the Astronomical Society of South Australia. So now that summer's well underway, there's plenty to look at in the sky, of course. We have constellations such as Orion and Canis Major, which are now more favourably placed for viewing, so we'll come to that shortly. And also there's plenty going on in the solar system. The inner planets and Mars are virtually in conjunction with the Sun, or nearly so. But all of the outer planets are readily visible over the next couple of months, and in particular Jupiter will be coming into opposition in January, so we'll talk quite a bit more about that later on in the show. And we're taking a break next month in January, so this show will actually cover the sky events for both this month, December, and also January 2026. And then the next show will be out in February next year. So as usual, we'll begin with a tour of the night sky. So we're looking at the night sky as it'll appear on the 20th of December at around 11:30 p.m. in the evening, about an hour after the end of astronomical twilight. So if you're looking in January, this is how the sky will look a little bit less than an hour earlier at around 10:30 p.m. So looking to the west, we can see that two of the constellations that we covered in a bit more detail in the November show, Pegasus and Andromeda, they've all sunk pretty much completely below the horizon at this stage of the evening. It's not too late to get a last look at M33, the Triangulum galaxy. It never rises that high though, so and even now it's getting even lower, so you would want to look at that as early as possible in the evening in the northern sky, pretty much as soon as it gets dark enough once you reach the end of astronomical twilight. Saturn is still reasonably well placed, still near the circlet of Pisces, and Neptune is nearby as well. So we'll take a closer look at that a little bit later on. Moving further up still, we have Cetus. One great object in Cetus is NGC 246, sometimes known as the Skull Nebula. Quite easy to locate the region that it's in because it's in the middle pretty much of this almost equilateral triangle at the head of Cetus. And if we take a closer look, you can see where it kind of gets the name from. It kind of looks like this. It's quite a large nebula for a planetary, relatively large. Sort of this sort of misty sort of background, and you can nebulosity, fairly round sort of shape, and the sort of the background stars sort of punch through it. And it also has these voids here, which kind of look like the eye sockets of the skull. And this region here usually looks like a sort of a dark bite taken out of one edge. So moving just a little bit further up, we can see here we also have Grus and Sculptor, lots of nice galaxies around here, including NGC 55, 300, and probably one of the finest galaxies you can look at in our skies, which is NGC 253, also known as the Silver Coin or Sculptor galaxy. And that's quite easy to locate as well, because if I zoom in a little bit, if you follow the line from Alpha Sculptoris, the brightest star in Sculptor, and you draw a line between that and Beta Ceti, about a third of the way along the line you'll get to NGC 253. And it's a wonderful galaxy. Usually fills unless you've got a really wide field eyepiece, it's great in any telescope, provided you've got a dark sky, and it pretty much fills the entire eyepiece. It's wonderful. And you'll see this beautiful oval-shaped halo, and especially as you increase the magnification, you'll start to see all of these dark lanes and a lot of mottling sort of along the axis of the galaxy. So looking into the northern part of the sky now, summer, of course, is well underway. So the great summer constellations are now really coming into view, such as Taurus, Orion, and Canis Major. In Taurus, just to the left of Aldebaran, we have the Pleiades, and Uranus is also nearby. So we'll talk more about that again later on in the show, as well as Jupiter, which you can see here lower down in Gemini. Orion Of course, the Orion Nebula is always worth a look at, and that's now quite well placed, and that'll get higher as the summer goes on. Nearby, we have our constellation of the month. We're going to return to Monoceros, a very faint constellation, but nonetheless has some really nice objects in it. So we'll look at just a couple of those later on. Further up, there's Canis Major. The brightest star in the sky is, of course, Sirius, right there. And then just above Orion, we have Lepus, the Hare. And there's a really nice, one of my favourite globular clusters, M79s, right there in Lepus. While we're in this part of the sky too, there's another three really nice planetary nebula that you won't want to miss, amongst others. Right near Jupiter here in Gemini is the Eskimo Nebula, or NGC 2392. Let's take those stars away. So this is quite a compact planetary nebula, so it'll need plenty of magnification to get a good view. So this is showing you a simulated view at about 270 times through a 12-inch telescope. And again, will, as usual, respond very strongly to a O3 filter. And then as we move up and look into Eridanus, there is NGC 1535, which is much like the Eskimo Nebula, quite compact, will bear high magnification very well, and it also has a compact shell to it. And then further up still, right near the zenith, again in Eridanus, is NGC 1360, sometimes called the robin's egg. And this is quite different to the other two nebula that we just saw, because it has quite a large apparent size and it has this sort of bluish hue to it. So this one I find is much better viewed at considerably lower magnification, because it has a lower surface brightness. And I would try it with a filter and without, but I find I usually get a better view for this one without a nebula filter. Looking towards the east now, this is in this region of the sky, the constellations will tend to be rising as the evening goes on. So we can see that the Argo Navis constellations, Vela, Carina, Pyxis, and Puppis, are now reasonably well placed, and they'll continue to get higher as the summer and the evening goes on, particularly Puppis. And this is a great time of the year, because you can look at both of the best emission nebula in the sky. There's the Eta Carina Nebula down here, and of course the Orion Nebula up there in the Sword of Orion towards the northern part of the sky. Moving now towards finally the southern part of the sky. So we can see there that given that Dorado is so high in the sky, there's the Large Magellanic Cloud and also the Small Magellanic Cloud. They're pretty much at their highest point at the moment. So excellent time of the year to be viewing objects in those two galactic neighbours. In particular, of course, in the Large Magellanic Cloud, besides all the little star clusters and nebula that you can see as you scan it, is the Tarantula Nebula, which you can't miss. You can even see it in the finder scope. And of course, over in the Small Magellanic Cloud, we have two quite good globular clusters, NGC 362, but of course that's overshadowed by NGC 104, better known as 47 Tuc, probably the finest globular cluster in the entire sky. So we'll now take a look at the calendar for December and January. So as we approach the summer solstice on the 22nd, of course, the nights are getting longer. So at the beginning of December, we have to begin our observation at around 10 p.m. in the evening, and that will go through to 4 a.m. in the morning. By the end of December, just past the solstice on the 22nd, darkness will begin at 22:17 and go through to 4:19 in the morning. And then by the time we get to the end of January, of course, during January after the solstice, the nights will start getting a little bit longer again. So by the end of January, we can start observing a little bit earlier again at 21:59, and that will go through to 4:57 in the morning. So the dark sky period for both for December is from the 13th of December through to the 22nd, and as it happens in January, the dates are pretty much the same. So the dark sky period in January will also be from the 13th of January through to the 22nd. Looking at the solar system now, and beginning with the innermost planets, we can see that Venus is already in conjunction behind the Sun, and so is Mars, and those two planets will be unobservable for the next couple of months. Mercury, you may catch a glimpse of in the early morning sky, but it's not a very good apparition. Its elongation from the Sun is relatively small, and then by the end of December and moving into January, it joins the other two planets behind the Sun and is therefore unobservable. But the outer planets, on the other hand, are still all quite well placed for observation, so just swinging around into the opposite direction. So we can see there that even though we're somewhat past opposition, Saturn and Neptune appearing close together in our sky are still quite well placed in the early evening sky. A little bit later on towards midnight and in the early hours, Uranus is also still a good object to take a look at as we passed its opposition last month. And of course, now's the time really to focus on Jupiter, which is reaching opposition in mid-January. So we're going to take a look at all of those outer planets and some of the things to look out for next. So we'll now take a look at some of the details of the planets. So firstly, beginning with Saturn and Neptune, these are best observed as early as possible in the evening. So as we saw, their relative orbits are aligned such as they appear still quite close together to each other in the night sky, still near the circlet of Pisces, just like the last couple of months. Now, since this show covers both December and January, the times are first given for mid-December, around the 15th of December, and then the times in parentheses are for mid-January, around the 15th of January. So Saturn is currently in December, transiting at 1930, and it will set at about 1:15 in the morning. By the time we get to mid-January, that will be a lot earlier at 1730. Still, the sky will be still quite bright, and it will set well before midnight at 2340. Its diameter is still hasn't decreased much from its opposition, still 16 arc seconds, and it's faded just a touch to magnitude 1.1. Nearby Neptune is just about 15 minutes behind the times for Saturn. Again, you'll want to catch it as early as possible in the evening, just as soon as it gets dark enough. Currently, its diameter is still 2.3 arc seconds, and its magnitude hasn't really changed at 7.9. Moving on to the northern part of the sky now. So Uranus came to opposition last month, I think in November. So currently still found quite near the Pleiades in Taurus. So it rises in December at 1820 and transits at a respectable time of 23:23. By mid-January, it'll be transiting considerably earlier and quite well placed for observation at 21:18 in the evening. So currently its diameter, pretty much the same as last month. Diameter is 3.8, so quite substantially bigger in the eyepiece than Neptune, at 3.8 arc seconds, and its magnitude is 5.6. So if you're looking from a dark sky and you've identified exactly where to look, you could, and you're dark adapted, you could see it with your naked eye, but it's quite an easy object in binoculars, even under a suburban sky, and of course through a telescope. So looking to Jupiter now, now's a great time of year to be viewing Jupiter, which reaches opposition on the 10th of January. Not only is the planet itself always worthwhile looking at, of course, but we also have the 4 Galilean moons and all the events that they produce, because they act like a bit of a mini solar system. So Jupiter itself, easy to find, of course, currently in Gemini, very bright at magnitude 2.6, and it's a massive 45.5 arc seconds. And I guess it might get a touch bigger as it approaches opposition on the 10th of January. So during December, it's currently rising at 22:10 and transits in the morning at 3:15. By the time we get to mid-January, it's getting a little bit more civilized to get a good view of it, because it rises at 8 o'clock in the evening, and it will transit at 1 p.m. So great time of year to start planning our Jupiter observations, depending on getting clear nights, of course. So I've provided a few resources to assist with that. And so firstly, focusing on the planet itself, one of the great features, besides all of the bands and festoons and so on, is, of course, the Great Red Spot, sometimes called the GRS. So Jupiter spins very fast. I think it's a bit less than 10 hours per rotation. So the Great Red Spot moves quickly. And also, there's sort of several opportunities every couple of days to see it. So I've provided two lists of when it transits. So that's when it's sort of crossing the middle of the planet. If you draw a line sort of from top to bottom, just like shown in this image here. So the list I've kind of given you a preview here is the transits which are visible from Adelaide. So that's when Jupiter is, of course, above the horizon and the sky is relatively dark. So I've provided those events for December and January. And I've also provided another list, which is in UTC or Universal Time. And for that, for our friends who are not in Adelaide, so other parts of Australia and more specifically overseas. So those times are in UTC, and so you'll have to then convert them to your own time zone and work out whether Jupiter is visible or not. So these times are the transit times. Because Jupiter is rotating so fast, these are probably the best times to see the Great Red Spot, but you can view it pretty much half an hour each side. So, for example, on the 10th of December, the transit time is 2:15, but the GRS would probably start to become visible on the edge of Jupiter half an hour earlier at around 1:45 in the morning. It'll cross the middle or the meridian at 2:15, and it will start to disappear on the other edge at around 2:45. So just bear in mind also, I've used software that I've written myself. I've checked the results for December, at least. They seem to be pretty much correct, but just be aware there could be a few variances. So always allow a little bit of time before the predicted time, just to ensure that you catch it. So the great thing about Jupiter is, in addition to enjoying the features on the planet itself, such as the bands and the festoons and the Great Red Spot that we just discussed previously, we can also look at the 4 Galilean moons, those 4 brightest moons that Galileo first discovered through his telescope, because they kind of form like a mini solar system and undergo all sorts of interesting events. So the 4 main ones are a transit. So that's when one of the moons passes in front of the face of Jupiter. We also have what's called a shadow transit, which I think are very spectacular. And one of the best events, that's where the actual shadow of the moon is projected onto the surface of the planet, and we can see that move across. And actually, when you see both a transit and the shadow transit at the same time, it kind of gives you almost this three-dimensional effect where you can really imagine that the moon is above Jupiter's surface as it passes across. We also have occultations, so that is where the moon passes behind Jupiter, and so it'll suddenly disappear at one edge and then reappear at the opposite edge. And we also have, perhaps best of all, eclipses. So that's where a moon either moves into or out of the shadow of Jupiter. And the wonderful thing about eclipses is the reappearance or disappearance of the moon occurs generally well away from Jupiter's disk. So it's quite spectacular to see a moon that's there, very bright, suddenly wink out or suddenly flare up from nothing in the matter of a couple of seconds. So to help you know when to look for these events, I've also attached two files. So this one we can see here is for Adelaide Daylight Savings Time. So that's UTC plus 10.5. And it's also been filtered so only those events that are actually visible from Adelaide are listed. So in other words, Jupiter has to be above the horizon and also the sky has to be reasonably dark. So here, for example, you can see here an Io shadow transit starts. So it's got the date and the time. So this means at 2:53, the shadow of Io will start on one edge of Jupiter. The transit start, in this case, occurred at 3:47. So that's when the planet itself is now in front of Jupiter's disk. So you've now got the shadow and the moon itself. And then finally, we've got the end of the shadow transit. So that's where the shadow exits on the opposite side of Jupiter. And that occurred at 5:08 a.m. And notice that the transit that started here, the end of this transit is not listed because from Adelaide, by the time the actual moon itself exits the edge of Jupiter, the sun would have come up and it would have been too bright. And so on for the other events. So you've got, here's an example of an occultation. Now I should point out there is a little bug in my code at the moment, which I haven't had a chance to fix. So what's happening is sometimes you'll see end eclipse and end occultation together. And notice that their times are very similar. So what's actually happening is, in this case, Io is ending the eclipse, but we can't see it because it's behind Jupiter, it's occulted. So what you need to do is you need to look at this and say, okay, well, the eclipse ended at 3:15, but the occultation actually ends at 3:22. So what you're not going to see Io come out of the eclipse. What you'll see in this case is simply when the occultation ends and Io will just suddenly appear from one edge, out from behind Jupiter. So in a later version of my software, I will fix that. And the other, but you will see the start of the eclipse here. And also I've listed the altitude, so that's handy to know whether an event's worthwhile viewing or not. So remember at the moment, the apparitions of Jupiter for the last few years and the next few years aren't particularly favourable. So I think the highest Jupiter will probably get is around 35 degrees or so. So any of these events where you see the altitude in the 30s, that's as good as it's going to get. Whereas if you see an event that's say 4 or 5 degrees, it's probably you're not going to see it very well or at all, simply because there's too much atmosphere in the way. So I've provided two versions of these files. So here's the Adelaide version for our friends interstate and probably more importantly overseas. I've also provided a UTC version. So these list all of the events, whether they are visible or not, because I don't know where you live, so I can't determine that. And because the times are in UTC, you need to then convert them to your own time zone. So please just note for this UTC version of the list, it does still list the altitude, but that is not valid because it's only valid for Adelaide. And again, because I don't know where you're looking from, I can't pre-calculate an altitude of Jupiter at a particular time for you. So that's a rundown of the lists. So what I've done from these lists, I've just picked out for both December and January 4 of what I think are some of the best events. I'll allow you to have a good look at the list, but I've pointed out what I think are some of the best ones. So on the 17th, there's a shadow transit of Ganymede, followed by an eclipse. And I'm going to go through that event in a little bit more detail than Stellarium, just so if you've had less experience looking at these events, you can sort of have an idea of what to expect. 18th, there's a shadow transit of Io, which is not too badly timed at 1 a.m. There's another eclipse here. And again, because of that problem I just discussed, well, not a problem, but you will see the eclipse end listed on my predictions, but you will actually only see the occultation end. So what will happen on the 20th? Europa will go into eclipse at 1:34, so you'll see it disappear. You will not see it come out of eclipse because it will be behind Jupiter, but what you'll see at 5:28 is you'll see it then emerge just from the edge of Jupiter at 5:28. And also on the 25th, so Christmas Eve and Christmas Day, if you happen to be up, there'll be the only double shadow transit that I could find. There's Callisto and Io, and you can see there's a very slight overlap of a bit less than 20 minutes where Callisto will still just be ending the shadow transit and Io will just be beginning at around 3 a.m. in the morning. And here also, I won't go through these in detail. I'll allow you to pause the video, but here's a few, I think, of the most interesting events that I've pulled out for January as well. So I just wanted to go through one of these events just to show you the sort of things to expect and how to interpret these times on the list. So here I'm looking at the Adelaide version, which is again in Adelaide Daylight Savings Time. And I want to show you the event on the 17th of December that we highlighted before. So this is a shadow transit of Ganymede, and also very shortly afterwards an eclipse of Io. So the first one here on the 17th, you can see here's the shadow transit. So there's Io, Callisto, Europa, and there's Ganymede. So at the moment, we're looking at about 17 past midnight. So I'm just going to advance time. And you can see there the predicted start time of the shadow transit is 37 past midnight. So I'm just going to advance time a little bit. And you can see there that as we pass into sort of 40 minutes past midnight or so, you can see there the shadow transit has begun. So even though Ganymede's right over here, its shadow projected onto Jupiter has now started to appear on the edge. And then as we advance time further, you can see that Ganymede is getting closer to Jupiter and its shadow is now making its way across the disk. And one of the things is Ganymede is much bigger than Io, for example. So Io is probably the most common shadow transit to see. It has quite a relatively small shadow. The shadow of Ganymede will appear considerably bigger. And so you can see there by the time we get to around 1:30 a.m., it's already made its way a third of the way across the disk. And then what I'll do is I'll just advance time now to 2:30. So we've just passed the middle of Jupiter's disk now, and Ganymede is now getting quite close. So you can see there that while the shadow transit is going on, you can see here that Ganymede is also going to start its actual transit at 3:01. So as we approach 3 o'clock, you can see the moon itself, Ganymede, is now getting closer to the edge. And then it'll appear to suddenly disappear, but it won't. If you look carefully, you'll then actually be able to see as a bright sort of spot against Jupiter's surface the moon itself. So the shadow is much easier to see because, of course, of the contrast. The moon, because it's pale and relatively bright, would be quite hard to make out over Jupiter's disk. So you may have to spend a bit of time until you acquire it. So then for a time, you'll see both the shadow and the moon itself pass across Jupiter's face. Then we can see at 3:50, the shadow transit will end. So that is when the shadow of Ganymede will exit on the other side. So we'll just advance time until we get to 3:50. So now we're at 3:40. The shadow has almost exited the edge of Jupiter. And you can see there at 3:50 or thereabouts, the shadow has now disappeared. Of course, Ganymede itself is still in transit, and basically you can't, it doesn't actually tell you on this list when the transit itself ends, because by the time Ganymede makes it to the other side of Jupiter, the sun would have already come up. So I've filtered those sort of events out. So the next event of interest to us is Io, which then goes into eclipse just 9 minutes later. So just about 9 minutes after you see that shadow disappear, keep a very close eye on Io. And as it approaches Jupiter, you can see that it'll suddenly disappear. So I went a little bit quickly there. So I'll just backtrack to 3:45. So there's the shadow of Ganymede. As we approach 3:50, the shadow has now disappeared. And less than 10 minutes later, keep a very close eye on Io. It'll still be quite a distance away from Jupiter at this point. And then as you approach the eclipse, you can see there I'm now moving by seconds. Within about 30 seconds to 1 minute, it's going to be very rapidly almost snuff itself out well before Jupiter. So it's really spectacular and very easy to see at the moment because these eclipses are occurring quite a distance away from the disk of Jupiter. So one of my favourite constellations to look at in summer is Monoceros. So that's, of course, going to be our constellation of the month for December and January. Somewhat neglected constellation in some ways because, of course, it's overshadowed by its neighbours. So you've got Taurus to the left here. Of course, you've got Orion above it and Canis Major. And they can tend to dominate that part of the sky. But there's some really wonderful objects within Monoceros which are really worth your time. The constellation itself is very faint. It's relatively faint. The brightest star, Alpha Mon, is only magnitude 3.9 or so, and the rest of the stars are generally magnitude 4 or less. So under a suburban sky, light pollution, you generally can't see any of the stars at all, or maybe just one or two barely. And under a dark sky, you kind of got the opposite problem because there's just too many stars and the constellation doesn't stand out very well. But what it makes up for in lack of constellation stars, it certainly makes up in terms of deep sky objects. So the first object I'd like to look at is Beta Mon, which is a double star. So there's Alpha Monoceros there, and Beta Mon is right here, and there's Gamma. So probably the best way to find Beta Mon is when you're out there under the sky is to look at, there's Sirius there, the brightest star in the sky, you can't miss it. And there's Kappa Orionis, so there's Rigel. So if you trace along the top of Orion, there's Kappa. So if you kind of form a triangle between Kappa, Sirius, Beta kind of forms the tip of kind of a flattened sort of triangle there. So Beta Mon's a very nice double star, widely separated. The separation's 7.1. It's actually a triple star. Sorry. One separation is 7.1 arc seconds. The other's around 9.8, and they're all sort of a bluish, whitish sort of color and brightness. So that's pretty easy triple star, and it should be you should be able to separate that in any sort of telescope, even a small 3-inch refractor or so. So our next object is really one of my favourite nebula pretty much after the Orion Nebula, say the Eta Carini Nebula. I would put this a good third in terms of the large so-called bright nebula, and that's the Rosette Nebula. So the Rosette Nebula you can find down here. So it's just near the star Epsilon Monoceros, right there, and you can see by the size of this Telrad reticle how big it is. This circle here represents 2 degrees, so it's a really huge emission nebula, and you can see where it gets the name Rosette from. And this black and white photo kind of gives a good impression of most of the features that you can see through certainly what I've seen through my 12-inch telescope under excellent skies. Just a little bit fainter, of course. And first thing you note, again, the size. I mean, that's at least a degree. In this case, it's official. I think it's actually more like 2 degrees, but Here the catalogue I looked at listed it as 1 degree by a little bit over 1 degree. So you'll need to use your widest eyepiece that you got, at least to start with, so that you can get some contrast with the empty space around it. And it also responds extremely strongly to an O3 filter, very, very strongly. So if you've got any sort of nebula, particularly an O3, I highly recommend that you try it. And what you'll see is you'll see this beautiful smoky reef of gas. It'll certainly look not completely dark, but certainly a lot darker in the center. And you can see in this photo, but also in this black and white picture over here, you can see these little dark channels. And you can also, on a good night, if it's nice and dark, you can see those dark channels sort of zigzagging throughout the nebulosity. So it's a really wonderful object. And in the middle of it, you'll see this, you can kind of see in this photo here probably better, you see there's a curve of stars there and there. So they kind of look like sort of two lines, sort of a bent sort of triangle like that. So that cluster is NGC 2242 in the center, and those stars have actually been created in that nebula complex. They're extremely hot young stars, very massive, and I think they're only a couple of tens of millions of years old, so they're very young. And it's actually the energy coming from these stars that's actually blowing that hole in the middle of the nebula. It's kind of pushing, the pressure from the stars has actually pushed that gas away. So one thing I should mention too, it's a very large nebula, so its surface brightness is quite low, and it's totally devastated by any form of light pollution. So if you attempt to look for this nebula under a city sky, where there's a reasonable amount of light pollution around, in my experience, generally you won't see even a hint of the nebula, even in a large telescope. So what you'll see, you'll know you're looking in the right spot. So because you'll still see NGC 2242. So you'll see that grouping of stars and those two kind of concave strings of stars, which is nice to look at in and itself. But when you get under a dark sky, it's great to see that cluster in the middle and then surrounded by that beautiful nebula around it. And the next object I want to look at is, because it's Christmas, of course, coming up on the 25th, so a Christmas show wouldn't be complete without the Christmas tree cluster. So that's also known as NGC 2264. And you can kind of see why it's called the Christmas tree nebula, because it kind of forms this sort of triangular base. And it's kind of got almost, well, it has got a star right at the top, just like a real Christmas tree. And you can see in this photo there's all that nebulosity as well, and I think that's also why it's called the Christmas tree nebula, because it kind of forms this sort of jagged edge, which kind of makes it look like a fat pine tree. So in the eyepiece, in addition, it's a wonderful star field in the Milky Way. You'll see the general shape of the Christmas tree cluster, these stars, and provided that you've got extremely dark skies and you're well dark adapted, you should see that some of this nebulosity as well, but it's quite faint, so you won't generally see all of these dark channels, but you'll see a beautiful sort of triangular cluster, and you'll see sort of surrounded in this faint but glowy sort of nebulosity that gives it this real sort of polish to it. And right up the top, you can see there I pointed out what's called the Cone Nebula. So that's an inverted dark nebula that sort of points towards the top of the Christmas tree cluster, considered quite the observing challenge visually. So it's considered harder than the Horsehead, for example. I've tried to see it on a number of occasions and have never been able to do so. People have seen it in telescopes as small as a 10-inch. It helps greatly if you have an O3 filter, or even better, a hydrogen beta filter if you have one, perhaps for the Horsehead. Also try it for this one. But the main requirement, and I think that's why I haven't seen it, is I haven't had a good enough night. You really need one of those nights where it's absolutely dark, low moisture, and completely transparent. But it's a good challenge to try for if you happen to be looking at the cluster. And finally, our last object is NGC 2261, or also better known as Hubble's variable nebula. And this is another nebula that I find a little bit neglected, visually at least. It's much photographed. It's a fantastic nebula again. It's a reflection nebula, and it's good really in any sized telescope. Unlike the Rosette, it will stand a certain amount of magnification because it's considerably smaller there at 3.5 arc minutes. And what you'll notice is you'll see a star, which is Mon, and then coming away from that star, it'll kind of look like a triangular or almost like a comet, this sort of fan shape, much like you see in this picture here. You'll see it kind of flaring away, and under high magnification on a good night, you can actually start to see some of that mottling and irregular shape in the tail as well. So it's a really nice object to look at, really pure white through the eyepiece. And the other thing that makes it a little bit unique is it's one of the few deep sky objects which is actually variable over time. And this very interesting picture from Wikipedia kind of shows you an animation. I think it looks to be over at 1 month intervals over a year. And you can kind of see how it varies in brightness and intensity. And you can see these waves that are kind of, if you like, traveling across the nebula. And they believe that's caused by the actual gas itself, and the nebula is not what we're seeing moving, but it's gas that's moving in front of the star Mon, and that sort of changes the amount of light that is projected onto the nebula. So it's a very interesting astrophysical object from that point of view as well. So there's many other objects in Monoceros in that region, of course, but we've kind of run out of time. But there's some starters for you to take a look at and explore this wonderful region of the sky. Thanks everyone for joining me in today's show. I hope you enjoyed it and found the information useful over summer. So like I said in the beginning of the show, we're having January off. So the Sky of the Month will be back in February 2026. So I wish you a Merry Christmas and a Happy New Year for later on, and clear skies, and I will see you in February 2026. Bye for now.